Did you know that that disk that came with your monitor that you probably ignored actually had a very important file on it, and without it, the colors on your monitor are not going to ever look correct? You didn't throw it away, did you? Well, don't worry, I did the same thing until I found out about this recently, and you can get that file online. What I'm referring to is called an ICC profile, and it basically contains information about your monitor so that your computer can then correctly display colors to it. And if you don't have this installed, then things are going to look wrong. It specifically has two different parts to it, possibly. The first part, which is it's always going to have, is the gamut information of your monitor. This essentially is the range of colors that your monitor is capable of. If you don't install such a profile and therefore don't tell Windows your capabilities of the monitor, it's going to assume that it uses sRGB, which is a very small color space, so that it's not going to be able to take advantage of the full thing of the monitor. A color profile may also contain color mapping information. This isn't always the case, and it's not 100% necessary to do it, but basically, if you do a full calibration with a calibration device, then it may detect that sometimes colors may be shifted slightly, and this basically allows the monitor to map them back and correct little inconsistencies, but that is in addition to the whole gamut information. So most important for most people, if you're not doing super color critical work, then you don't have to have the second part, but you do at least want to get some kind of color profile because that'll at least contain the gamut information for your specific monitor. So in this video, first I'm going to go over why this matters and what the ICC profiles do and don't do. So that's important to watch so you don't go in expecting it to do one thing and then complain about it when I explain that that's not what it's for. Then I'm going to show you how to get an ICC profile for your specific monitor and how to install it. I'll try to make it easy to understand and follow, and I'll also put timestamps in the description and put the chapter somewhere so you can see what's going to follow. All right, so first let's go over a crash course of what is known as color management. Now, I'm only going to explain the essential parts here that you really do need to understand for why you're doing the things I'm going to explain in the video. There's a whole field about color management that I'm not even going to get into. Just going to break it down just for the essentials so you know what's going on. All right, so obviously, as you probably assume, not every monitor is exactly created equal. They have lots of different capabilities of brightness and color capabilities and dynamic range, all that sort of stuff. And like I mentioned before, the actual set of all colors that the monitor is capable of displaying to you is called the color gamut. We can actually graph this information. So if I look at my one monitor, it's the 27GP850 from LG. Sometimes you'll see the gamut graphed in 2D, it'll look like this, but for real, it should be a 3D graph because it includes not just the colors on the horizontal, but also the brightness on the vertical, so dark on the bottom, bright on the top. And basically how this works is the further out from the middle of the graph, the more saturated the colors are. Now, every single output device, whether it's a projector, a monitor, even a printer, they're all going to have a color gamut because they reproduce colors and they're only going to be able to reproduce certain ones of them. Technically, each individual unique device is going to have its own unique gamut. So that means that if you have two monitors that are the same model, they are going to slightly have different gamuts because of manufacturing differences, you know, who knows what reason, but they are going to be pretty close. Then, as opposed to a color gamut, there are other sets of colors known as color spaces. Some common ones are sRGB, Adobe RGB, Display P3, DCI P3, you may have heard of some of these. And these are essentially just reference standards that people decided to make up to make it kind of easier to describe the capabilities of different monitors and kind of have a few different targets that manufacturers may shoot for, basically. So one really common one you may see is sRGB. This is extremely common, but it's kind of small. But a lot of times you'll see a monitor specification say, oh, it contains 100% of sRGB or 110%, which means it could do more than sRGB. But because sRGB is so common, it's commonly used on the web and stuff, just it's kind of a standard because pretty much every display at this point can display those colors. And just for reference, you can see some of these color spaces mapped onto a big giant color space called the CIE 1931, which is actually a theoretical color space that supposedly contains all human visible colors. So you can see that even some of the biggest color spaces that we've created that most monitors are not even capable of, even those don't contain all the colors that the human eye is capable of seeing. So why am I telling you all this? Why is this important? Well, it kind of has to do with sRGB, which is, again, the most common and most standard, and that's just because way back in the day when there were CRT monitors, all of those generally kind of had a sort of similar color gamut, and they just made sRGB because basically that was something that a lot of monitors were capable of. And because this color space is so common, if you have not set a color profile in Windows, which you probably have not done, then Windows is going to assume that any monitor you're connecting just uses sRGB color gamut and doesn't know that it may be capable of more or less. These days, many high to even mid-range monitors are capable of displaying way more colors than just sRGB. For example, if I compare the gamut of my monitor, the 27GP850, to sRGB, it's way bigger. But if I didn't have a profile telling Windows that, then it doesn't know what these capabilities are. It's just going to assume the smaller one. Now, hearing this, you might assume, oh, well, Windows doesn't know that the monitor is capable of these more colors, so it must be only showing a small number of colors and not using all the colors of the monitor. But that's actually not the case. It's kind of the exact opposite problem. Now, this is definitely going to be an oversimplified explanation, so don't rage at me in the comments if you know how this actually works. But let's say you're using a program like a photo editing program, and it wants to display a certain color to you, but you do not have any kind of color profile installed, and so your computer's just assuming it's sRGB. So say the computer wants to display 75% blue at some brightness. The brightness doesn't matter, but it knows that the correct color is 75% blue in the sRGB color space, which for all it knows you're using, so that's the right one to put out. So it sends a signal to the monitor, hey, show 75% blue at this pixel, and the monitor does what it's told. However, 75% blue on the big color gamut of the monitor is a lot more saturated than 75% blue on the sRGB space. So what is displayed on the screen is going to be way oversaturated than what the program intended and what the person creating the picture may have been seeing. So as an example, I made this test image in Photoshop. It's just some RGB bars that go from 0 to 255 color values on the right. So 255 green, red, and blue. And those are the values that the computer is using to decide what to display. Now, one of these images is tagged with sRGB, which means I embedded the sRGB color space in it, which tells the computer, hey, this image is supposed to be in sRGB. And another one, I used display P3, which is a much bigger color space. It's common on like Mac devices, iPhones, and stuff like that. With a proper profile installed on the computer, I'm gonna show this on the camera. I hope it shows up correctly. So we can see that the sRGB one looks kind of normal. You wouldn't think anything of it. But if you go to the display P3 one, you can see that it's now way more saturated. And that's because the embedded profile said, yes, I want 255 red, green, and blue, but in the sRGB gamut, which is not as saturated as 255 on the display P3 gamut, or color space, I should say. But now if I disable the profile and just use the default one in Windows for sRGB, actually looking at both of them, they pretty much look the same, at least on the most saturated side. In the middle, there's some differences, but I'm not gonna explain why that is. But on the right, they pretty much look exactly the same. And that's because even though these images are tagged with different profiles, Windows has no reference for how that relates to what the monitor can show. So it just says, all right, whatever, just show 255 value, sends that to the monitor, and the monitor just maxes out 255, which is really saturated. Also, side note here, notice I'm actually using the old Windows Photo Viewer instead of the new Photos app, and that's because the old one is actually color managed. It shows correct colors, whereas the new one in Windows 10 does not. I'll explain that later, but just be aware of that. Now you might be thinking, now wait a minute, I actually like a saturated look when I'm just browsing the desktop and stuff. I don't want it to look all dull and whatever, but that's actually not a problem because in Windows, it's only going to apply the profile on color managed applications or images that are tagged as having a certain color space. So when you're just browsing the desktop or browsing the web, most of which does not have any kind of tagged color space because it doesn't really matter, then you are going to get that very saturated look that does look kind of nice. But the reason you want to have a proper profile installed is if you do come across an image that is tagged with a specific color space, then you are going to be seeing it accurately and not oversaturated. Now, there are some other problems you may come across if you don't install a profile. For example, in addition to seeing some images as oversaturated, say you do some photo editing or video editing on a computer and it looks perfect. Then if you go to export it, upload it to YouTube, whatever, and then go to view it on another device that is properly calibrated, for example, a lot of phones are properly set up as having a correct profile because there's only one screen per phone model. It's easy for those manufacturers to set that up. So when you go to look at the photo on those other devices, then it may look undersaturated, less saturated, and other people are going to see it as that as what you saw on the computer. So it kind of goes both ways. All right, so now that you know why it's important, let's talk about where to actually get an ICC profile for your specific monitor. Now, probably the easiest, simplest way is to maybe look on your manufacturer's website. Also on that disc that came with the monitor might be on there. For example, from my monitor in LG, it actually was included in the same zip download as the drivers. You just open it up and it'll either be an ICC profile, .ICC file, or .ICM. They're the exact same thing. It's just that Windows, for some reason, by default calls it ICM, but they are exactly the same no matter the file extension, ICC, ICM. But if you can't find an ICC profile from your manufacturer, it's actually not really a problem. I would actually recommend, if you can, don't use the one from there. I'll explain why in a second. Instead, there are a lot of places where you can get a specific ICC profile that people have made for your monitor. You can either just Google the name of your monitor and the model number and then ICC profile, someone might have made one, or a lot of times review websites like Artings, TFT Central, those are some websites. A lot of times in the review, they'll include an ICC profile. So to show you exactly why it is probably a better idea to go to one of these places that is custom-made profile, let me go to the computer and I'll show you exactly why. All right, so I'm in a program that's for analyzing and viewing color spaces and color profiles. If you're wondering, it's called ColorThink, but it's kind of expensive. It's not free. Anyway, I'm going to show you why it's probably better to get a actual third-party color profile that's custom made for your monitor as opposed to just downloading the manufacturer one, which is probably going to be somewhat generic. So this is the color profile that I made myself with my own colorimeter. And as you can see, this is the true 3D volume version, but projected below it is the 2D version, and we can actually graph it in 2D. And this is what it will look like. And this is a relatively wide gamut monitor. So let's compare that to sRGB. So what I'll do is I'll bring down the opacity here. So you can see that inside the sRGB color space is quite a bit smaller than the gamut of the monitor. You can see that in the greens, the monitor can do a lot more than sRGB, the reds, really everything. And also in the 2D view, you can see that the gamut fully encompasses sRGB. And actually the monitor also advertises as being 98% of the DCI-P3, and we can view that one as well. And you can see that it pretty much does. It is missing a little bit in the greens, yellows, and reds, but for the most part, it does have all that coverage. And the DCI-P3 also fully more than covers the sRGB. And I also want to point out that I know my color profile that I got is relatively accurate because this is another one that I downloaded from Artings. They did a review and they also did a color profile of their own. And as you can see, mine pretty much exactly lines up with theirs, maybe just a little bit of a discrepancy just from the individual panel. So just showing mine again, here is the main point I want to make, because this is the profile downloaded from LG's website. You can see, so if I toggle it on and off, you can see it's the one on the right. Yes, it is much bigger than sRGB, so it's going to be probably better to have installed than just the standard Windows sRGB color space, but for some reason, it really doesn't get all of the true color space of the monitor. In fact, it goes over some of the parts and cuts off a huge chunk of the green and blue, not just in the actual gamut, but even in the sRGB gamut. And I believe this is because LG just kind of included a generic UltraGear ICC profile that I guess they made for basically their whole line of UltraGear monitors, but not necessarily for each individual model, because in the name of the profile, it's just called LG UltraGear. So if you were to use this, you would not be able to even take advantage of all these colors, or it would look wrong, or even some of the sRGB colors would not look right. So that's why it would definitely be better to download even one from like Artings. This one obviously is really close to what I got and fully encompasses the sRGB and also the DCI-P3, and this is really close to the true gamut. That's the one you want. Finally, let me point out, I know this graph is slightly different than the one I showed before, which had triangles that looks like this. These are just two different ways of plotting the different color spaces. So this is called lab, this one's YXY. They're the same exact thing, it's just plotted differently. All right, so at this point, let's say you've downloaded whatever ICC profile for your monitor. How do you actually go about installing it on your computer, on Windows? Well, the first thing you should do, if you have any programs like Flux or anything else that might be modifying the colors of the monitor, turn those off while you install it. You can turn it back on afterwards, but it might mess it up if you have it enabled while you're doing this. Now, first thing I would recommend is go to whatever file you downloaded and rename it to be something unique that better describes what it is. So for example, it might be LG 27GP850 manufacturer profile, or RTING's profile, wherever you got it, something like that. And to make it even easier on yourself, you can add an exclamation point to the beginning of the file name. That's because usually exclamation mark comes first alphabetically before characters, and I'll show you why that'll be important later. Next, you want to double click or right click and install the profile. And then what you have to do is go into the start menu and search for color management. Next, in the drop down in this window, if you have multiple monitors, make sure you choose the right one. Or if you have one monitor, it doesn't matter, but you can click identify monitors to make it easier to see. In the box below, you may or may not see any profiles. These are not all the profiles that you have installed on the computer. These are just ones that have been associated with the monitor. So if you haven't done any of this before, this will probably be blank. So what you want to do is click add, and then now you will see a list of all the ICC profiles that are installed on the system, and many of these are just pre-installed generic profiles that aren't even necessarily meant to be used for monitors, but instead are used for like converting from one color space to another. So if a image is tagged with the P3 color space, then the computer knows how to go from P3 to the other one because it's installed. Anyway, we need to find the monitor specific profile that we just installed, which is going to be under the ICC profiles group. Now, this menu sucks. At first glance, it seems like nothing is sorted. There are two columns. The left column is called profile name, and the right column is called file name. But eventually I realized what was going on. It turns out this whole menu is sorted based on reverse alphabetical order on the file name column on the right. So not intuitive, but that's why I said to add the exclamation mark in the beginning of the file name. So now you can literally just scroll all the way to the bottom and the file should be there. Anyway, next click to highlight whatever monitor profile you want to install, and then probably leave add as advanced color profile unchecked. Now there is very, very limited information about what this checkbox actually does. After a lot of digging, I think it has something to do with HDR and wide color gamut, but some people say their profiles don't work if they check it, but it does if they don't. And because really no one can figure out what it actually does, and there's not really much documentation on the Windows site, I would just leave it unchecked because it doesn't seem to cause any problems. So with the profile highlighted, just click OK, and now the profile will show up in this list. So you can actually enable it because it's now associated with this monitor. And to do that, you click and highlight it again in this thing and click on Set as Default. Also in here at the top, there's a checkbox. Make sure it is checked where it says use my settings for this device. Also, alternatively, if you go into the Windows 10 settings and then system settings and then display, you should also see these same profiles in the drop down here, and you can switch between them there or just in the color management window. Regardless, one more thing you might have to do is go into the advanced tab, and you probably need to make sure that use Windows display calibration is enabled. It's probably going to be grayed out though. So to enable it, click on where it says change system defaults. And this is going to bring up a window that looks exactly like the one before, so it might be a bit confusing, but this is just for system defaults and the other one was just for user profiles. So don't worry about changing anything else in the system defaults, it's not really necessary. And the user one actually overrides the system default. That's why we check the use my setting. So in here again, go to the advanced tab, and now you should be able to check use Windows display calibration, and then you can just close that. Now, even after you enable a proper profile for your monitor, you're probably not gonna notice an immediate difference. It's not like anything on the desktop or whatever is gonna change colors immediately, because we just changed the color gamut of the monitor that Windows knows it has, which it was pretty much already maxing out in the general desktop anyway. Like I said, it's only really gonna make a difference if the software you're using to display some kind of image is actually color managed, and not every program is. It's basically up to the developer if they decided they're going to be working with color sensitive images and stuff like that. So not everything is going to do that though. Now, on the other hand, if you actually did a full calibration of the monitor to remap some of the colors, then actually Windows will, in addition to using the full gamut, might actually shift some of the colors even on the desktop. So if you see a shift in colors, it probably was doing that remapping, which really you should only do if you have an actual colorimeter. If you just downloaded someone else's profile and it shifts everything, then that's going to be shifting colors based on inaccuracies in their monitor. You don't really want to do that. One kind of easy way to tell is by actually looking at the file itself. If it's really small, like only a few kilobytes, it probably just has the gamut information. Whereas if it's several hundred kilobytes or even a megabyte or more, then it probably has a lot of color mapping information in there. So you might not necessarily want to do one of those. Now, speaking of color management, I kind of mentioned that I actually prefer to use the old Windows Photo Viewer, and that's because it is actually color managed. So if you open a tagged image that has a profile attached to it, it's going to show images correctly, whereas the new Windows 10 Photos app is not color managed. It's going to show the wrong colors, which why this is unfathomable to me, why they would make a Photos app that is the default one in Windows 10. It's actually the newer one. It's not color managed. I don't know what the heck Microsoft is thinking, so stupid, but luckily you can just use that old one, and it might actually be installed already on your computer. If you upgraded to Windows 10 from a previous version, then it probably carried over the old Windows Photo Viewer. So I believe even 8.1, definitely 7, you should have it installed and you can run it right away. Now, if you installed Windows 10 from scratch by yourself, or you bought it pre-built, then the Windows Photo Viewer is not going to show, but it is actually still hidden away on the computer. It's just disabled. You have to enable it using a registry tweak. I'll actually link to a How to Geek article where they go through how to do this, and they actually do have a registry tweak you can download, and it'll just automatically enable the old Photo Viewer. And the file is safe. How to Geek is one of my favorite websites, so you can definitely trust it. And in the article, they also explain how to set it as the default image viewer in Windows 10 if you didn't know how to do that already. Or you could just go out and download a third-party free image viewer that is advertised to be color managed. I don't really know any off the top of my head, but they might be out there. Still though, if you are using the old Windows Photo Viewer and you have a proper color profile installed, you should now be confident that at least the images you look at are going to be accurate if they're at least tagged with a certain color profile, which some are. Hopefully this video helped and you learned something that you might not have known before. So let me know down in the comments if you liked this video, and definitely give it a thumbs up if you enjoyed it. If you guys want to keep watching, the next video I'd recommend is where I was talking about 10 ways you might be using your computer wrong. So definitely check that out with the link right there. So thanks so much for watching, guys, and I'll see you in the next one.